This episode is for P0113 intake air temperature sensor 1 circuit high on a 2019 to 2024 Ram 1500DT with the 5.7HEMIGas engine. In plain terms, the PCM may be seeing an intake air temperature signal that does not make sense electrically. The check engine light may come on, and depending on the fault, drivability can vary. The broad areas to keep in mind are the IAT signal circuit, the sensor ground circuit, connector condition, the IAT sensor itself, and only after the circuit checks, the PCM. The IAT sensor is a 2-wire, 5-volt sensor. The PCM supplies the IAT sensor with a 5-volt signal and a filtered ground, then reads that signal as an air temperature value. Before testing, understand when the PCM is looking for the fault. This diagnostic runs continuously with the ignition on and battery voltage greater than 4 volts. The set condition wording says the PCM detects that the IAT sensor input voltage is below 43 volts depending on calibration for 2-3 seconds. Since that set condition wording does not line up cleanly with a circuit high title, do not make a repair decision from that line by itself. Use the actual circuit tests and branch points that follow. Start with the basic system checks before jumping into the P0113 test path. Then use the scan tool to read codes in all ECUs, record the codes and the environmental data, and save the vehicle scan report. Clear the codes, turn the ignition off for a minimum of 0 seconds, then turn the ignition back on. Reproduce the captured operating conditions as closely as possible and read the codes again. If P0113 does not return, handle it as an intermittent condition. If it does return, continue with the circuit testing. With the ignition off, disconnect the harness connector at the IAT sensor side of the circuit being tested. Use the vehicle wiring information to stay on the correct IAT temp signal circuit. Turn the ignition on and measure voltage at the component harness connector with a DVOM. On a 5.0-volt signal or reference circuit, normal voltage should be between approximately 4.8 and 5.2 volts. For this test, if the IAT temp signal circuit is above 5.2 volts, treat that as a short to voltage path and move into isolation testing. If it is not above 5.2 volts, move on to checking the signal circuit for open or high resistance. If the signal circuit measured above 5.2 volts, turn the ignition off before doing resistance or continuity checks. Isolate the circuit by disconnecting the ECU and every component connector that contains that circuit, while leaving the inline connectors connected. At the ECU harness connector, put one DVOM lead on the IAT temp signal circuit, then probe the other circuits at that same connector with the other lead. If you need to work at a PCM harness connector, use the GPEC diagnostic adapter 10436 rather than probing the PCM terminals directly. With the circuit isolated, there should be no continuity from the IAT signal circuit to any other circuit. If continuity is found, repair the short between the circuits that show continuity, then verify the repair. If no continuity is found, the path moves to connection checks later in the flow. If the signal circuit was not above 5.2 volts, keep the ignition off and isolate the IAT temp signal circuit by disconnecting the ECU and the component harness connector for that circuit. Before measuring the circuit, measure the resistance of the DVOM leads themselves, because the leads add resistance to the reading. Measure resistance from the component harness connector to the GPEC adapter side of the circuit. If the test requires access at the PCM connector, use GPEC diagnostic adapter 10436 instead of probing the PCM terminals directly. The adapter can add up to 1.5 ohms of resistance to the circuit, so keep that in mind while evaluating the result. If the IAT signal circuit resistance is below 3.0 ohms, continue to the sensor ground circuit check. If it is not below 3.0 ohms, repair the open or high resistance in that circuit. Then verify the repair. Next, with the ignition still off, isolate the K915 sensor ground circuit the same way. Disconnect the ECU and the component connector that contains the circuit. Measure the DVOM leads first, then measure resistance from the component harness connector to the GPEC adapter side of the sensor ground circuit. The same PCM terminal caution applies here. Use the adapter where needed instead of probing PCM terminals directly. Again, the adapter can add up to 1.5 ohms of resistance. If the sensor ground circuit is below 3.0 ohms, continue to the sensor simulation check. If it is not below 3.0 ohms, repair the open or high resistance in the sensor ground circuit, then verify the repair. For the sensor simulation check, keep the ECU harness connectors connected to the ECU. Disconnect the IAT sensor harness connector. With the ignition off, connect a fuse jumper between the IAT temp signal circuit and the K915 sensor ground circuit at the IAT sensor harness connector. Turn the ignition on and read DTCs with the scan tool. If the scan tool shows the sensor signal circuit low DTC with the jumper in place, the PCM can see the pulled low signal, and the supported repair is to replace the faulty IAT sensor. Then verify the repair. If the PCM does not detect that low signal with the jumper installed, continue to the connector and PCM-side checks. Before making a PCM call, check for any applicable bulletins. Then disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect the connector bodies and terminals for proper installation, damaged locks, corrosion, signs of water intrusion, whether seal damage if equipped, bent terminals, overheating from a poor connection, terminals pushed back in the connector cavity, spread terminals, and weak terminal tension. Repair any condition found. Reconnect everything fully seated with the locks engaged, clear the codes, and operate or test drive the vehicle under the captured operating conditions. If P0113 returns after those checks, the supported next repair is to replace and program the PCM, then verify the repair. If the code does not return, the wiring or poor connection problem has been corrected. Keep verification separate from the individual circuit tests. After any repair, clear the code, operate the vehicle under the conditions that set the fault, and confirm P0113 stays gone. The key on this one is to prove the signal circuit, prove the sensor ground, simulate the sensor response, and inspect the connections before calling the sensor or the PCM. If connector views or terminal identification are not available, pause. Recheck the earlier diagnostic path and get the correct vehicle wiring information before probing so you are not guessing. For more diagnostic training, visit stepdiagnostics.com.